Presentation will be really focused on IoT, and I will try and tap in as much as possible into our experiences that we have with smart cities and smart buildings today. So I lead up worldwide public sector strategy and go-to-market for the Internet of Things. And whenever we begin any discussions with our customers, we always start with a simple question, which is, if you knew the state of everything and could reason on top of that data, what problems would you solve? Now, a lot of what you're hearing today is really, our mission is to make this a really good customer experience. And in this case, if you knew the state of everything and all of your devices and can reason on top of that, from a customer perspective, what problems would we truly solve? Now, we work with all of our customers on those key questions. Next slide, Kieran, please. But what we're seeing is that the problems are, just keep going through, the problems are not as easy because there's no single solution for arenas such as smart cities or smart buildings or in any part of what we do. So it doesn't come down to a single solution. Smart cities and communities, what we're seeing have segment-specific use cases such as transportation, public health, public safety, smart buildings, and each segment in turn, if we drill down, has additional levels of use cases. And what we're seeing, for example, with smart buildings is how do we manage HVAC, how do we do water and energy management control and waste control. So it becomes highly complex the more we drill down on these particular areas. And to add to that complexity, what we see is each requires a combination of technologies. So customers don't buy IoT. They buy this combination they buy a selection of technologies to meet a business outcome, which is IoT, analytics, workforce automation, security solutions that are applicable to a particular segment. Next slide, Kieran. I'm just trying to catch up on time to make sure that we get to services. So what's changed? So we've spoken about, if we knew the state of everything, what would we do? We've spoken about, very briefly, the complexities that we see with smart cities and smart buildings. There is no single solution. However, the evolution of IoT has now got us to where we need to be to begin to build these complex solutions. And it's also given us an understanding of what we need to do next to be successful. So what we've seen over the last few years, so the Internet of Things is nothing new. It's not new. So customers have embraced and understand the value of connected things. They're everywhere, which in turn is driving growth of connected devices. So why we have varying estimates on how many there will be, estimates show potentially 75 billion devices will be on this planet by 2025. However, the more devices we connect, the more data we gather. And we are, in fact, creating, and most of us are seeing that, an unprecedented amount of data in the zettabytes, most of which is still unused today, let alone accounting for the growth that's coming our way. So with connected things and massive amounts of data and a few years of pilot experience to test technology, business outcomes, and ROI, so we're moving now towards the final, not the final, but the next three phases. So if you look at this slide, in all examples, what we're seeing is there's a requirement now to develop a strategic roadmap development plan. There's a requirement to do that based on a data-driven strategy, and there's a requirement to do that, with a citizen-centric approach, regardless which type of use case we're talking about. All of which we need now moving forward to really create unique customer experiences, innovate, and identify and implement efficiencies. Next slide, Kieran. So to help customers through this evolution, from the first three to move into the final three, emerging technologies will become and will combine to play a vital role. So this includes IoT components such as edge and security, but also analytics. You're going to see it combined with AI ML and data lakes for storage, and also augmented reality for improved customer experience. So again, it comes back to that it isn't one solution. We require a combination of solutions to meet business outcomes. Next slide, please. So these emerging technologies that we spoke about are key because ultimately it's all about the data. And those emerging technologies define how we collect that data, how we process it, how we act on it, store it, share it, and visualize it across segments for different use cases. So it's critical when we're working with customers to build smart cities and smart building strategies to have a clear technology and data-driven strategy that allows for the scale and accessibility of the data. So it really is all about the data. Next slide, please. So where to begin, right? Through our experience in the last number of years of implementing IoT, our customers are adopting 4 types of automation stages to create smart solutions ranging from a basic, how do I manage my Fitbit, my washing machine, right up to a smart city strategy. So it's in 4 phases. So firstly, what we see, and it's the easiest to implement, is data sensing and metering. And this is the most basic type of smart use case, and it enables asset management, tracking, and predictive maintenance. For example, is my firmware up to date on the heating system? Is the light fixture on level 4 responding? The second box is the real-time integration and historical data monitoring. For example, a water filter is due for maintenance based on number of hours in use, or adjust heating and cooling temperatures in buildings based on seasonal temperatures. So the third box is data modeling, analytics, and machine learning, right? So this enables devices within buildings or in cities to act based on data collected and self-improve over time through local trained models. And this is now moving towards, as you can see, the direction of not just taking in data and acting one time on what we learn, but it's also enabling our cities and our buildings to self-learn. And lastly, visualization through a single pane of glass for different audiences. If we look at building management, we have operators, we have community and city officials, and we have tenants. And that single pane of glass really ties everything together to provide a certain customer experience. Next slide, please. So how do we help there? So AWS have developed a set of, so AWS IoT consists of a set of services that will allow you to build out those 4 stages that I've talked about, those 4 stages of automation, and really help manage complexity of multiple solutions. So in building out those 4 stages, 3 questions come to mind. So if I go from the bottom to the top, it's how do I connect my devices? How do I manage and control my devices in the cloud? And lastly, coming back to the data, how do I extract value from my data? Next slide, please. And to answer those questions and accelerate IoT implementations, so AWS developed, we listened to the customers about the requirement to make those 3 stages, answer those 3 questions, and we developed 10 IoT services that enable edge-to-cloud connectivity, which is the bottom table, which allow control and management of devices, which is the middle part of this table, and that allows analytics and visualizations of data to affect business outcomes, which is the top. Next slide, please. But unlike the previous slide, it's not a stack, because again, it's all about the data, and I'll be saying that a number of times during this presentation. So while collecting and acting on it one time is important, its true value for smart cities and buildings comes from continuously collecting that data, analyzing it, and using it to improve efficiencies, operations, and enable innovations. Hence, you can see the cycle, right? From the right-hand side, we have the services that allowed collection and connectivity. Moving to the left, we have the services that are actually in the cloud that allow us to store that data. And then we have the top left, which is our analytics services, which allow us to visualize and act on that data. So it's really key. We have a set of 10 services, but we see it as a virtuous life cycle where we continually collect data and improve on what we learn. Next slide, please. So how do these components look, these AWS IoT components look for smart cities or smart buildings? So on this slide, what you'll see is an example architecture for a smart building. And it shows from left to right how AWS IoT managed services, how they combine to enable disparate devices on the left, speaking different protocols to connect to the cloud securely and at scale. So these devices can be managed locally at the edge or in the cloud, and data collected from these devices can be analyzed and acted upon by predefined services and templates also at the edge or the cloud. So as we move towards the right, the predefined dashboards enable you to quickly view data collected and begin to understand trends and act on them. So it really is, I think one of our customers called it, he loved the fact that he had a selection of what he called Lego blocks that he could piece together very quickly to be able to collect data, store it in the cloud, and act and visualize on it through these predefined services. Next slide, please. So let's look at question 1 at the bottom, right? How do I connect my devices and operate at the edge? Next slide, please. So let's just touch briefly on what we mean and why the edge has become a game changer with the Internet of Things. What we found and what our customers found is, what if you simply cannot upload data to the cloud? For example, due to lack of connectivity, like if you're in a mine or an oil rig. What if you cannot afford to upload data to the cloud because your smart car or your manufacturing line produces terabytes of data every hour? Or you're not allowed to upload data to the cloud because your devices operate in hospitals, like, for example, Philips Healthcare. So AWS IoT at the edge, those handful of services that we have at the edge help you with these challenges with 2 key edge services, which is Amazon FreeRTOS and AWS IoT Greengrass. So FreeRTOS, right? So this includes it's a kernel, the FreeRTOS kernel, and software libraries that make it easy to securely connect small, low-power devices to more powerful edge devices and gateways, running Greengrass or AWS cloud services like IoT Core that we'll talk about briefly. So FreeRTOS, it provides everything you need to easily program connected microcontroller-based devices. It allows you to collect data from them and send to AWS IoT for analysis and action, right? And it also allows the scale of IoT applications across millions of devices. So really what it is, it's an operating system that we can install on these microcontroller services and a library so that you do not have to create that library yourself in order to connect your device to cloud. Next slide, please. So once we have installed these libraries on the operating system in our microcontrollers, then we have an option to, as I said before, there are challenges with just sending that data to the cloud, and there's a lot of reasons for to not do that immediately, or if there are limitations. So here we have a service called AWS IoT Greengrass. So it works at the edge, and it embeds local Lambda compute, local messaging, local device shadows for data and state synchronization, also ML inferencing that we're going to talk about, as well as security of communication in connected devices. So it's effectively a software capability that embeds in devices, and it allows you to have Lambda inside those devices, so you have flexibility in the compute and the events that trigger it. And I think just imagine IoT Greengrass that can be in a connected car. It can be in a train. It can be on every floor in a building, for example. So Greengrass in of itself has allowed the edge to be in many different places and have power, and have these capabilities in, not necessarily in the cloud initially, but all local. So what are our customers doing with Greengrass? Next slide, please. So what we're seeing today is there's a spectrum of customers that are using Amazon FreeRTOS and Greengrass. that run on gateways, and also powerful devices that manage edge operations. Some examples from here would be Hive. So Hive uses Greengrass for command and control on hubs in smart homes. Electronic Caregiver, it uses Greengrass for machine learning inferencing on home healthcare devices. And if we look at the grid, Vantage Power uses Greengrass on in-vehicle devices for tracking and logistics. So there are many different ways today that our customers are using Greengrass. Next slide, please. Let me get to the second part of this. So we've talked about the edge, which is the bottom, and now we're going to talk about the cloud. So how can I control and manage and secure my devices? So if we go to the next slide, please, Kieran. So we have a service, and it's called AWS IoT Core. And this is based in the cloud, and it forms the backbone for AWS IoT deployments. And it allows you to securely connect all your devices and handle all of the data that's coming from those devices at scale. So remember, we talked about the more devices that we connect, the more data we have, and we need to find a way to be able to securely send that data to the cloud and store it at scale. So it allows you to, I'll say it again. So it allows you to securely connect devices, and also at the same time, it can route, process, and act on data and messages coming from all devices. So it really takes away that heavy lifting of you having to create that. We have that managed service to be able to do that. Next slide, please. So the reason I put this slide in is I spoke only about AWS IoT being 10 core services, but this core component of AWS IoT is fully integrated with all other AWS services. Really, that enables you to reason on top of all that data collected from devices. So it's built on our global infrastructure, and which now has over 165 services. And AWS IoT integrates with many of these services, many of which, or most of which, would be necessary for smart city or smart building projects, but are typically prohibitively expensive to build on premises, like Amazon Rekognition or Kinesis or Amazon Connect. So you can make use of these services to expand on AWS IoT capabilities to expedite delivery of new services. Next slide, please. Next slide. Yeah, thank you. That's perfect. So I wanted to have this in there because we spoke at the very start about very segment-specific services. Segment-specific use cases like transportation, like smart home and smart cities. So what our partners and customers have done is that they have built these services on top of the AWS IoT platform. So they've created a smart city platform. They've created a smart building one. And examples would be Deloitte, who's created City Synergy, Ayla Networks, and in this example, Cognizant. And so they've created connected places that allow facility managers and other stakeholders to gain insight and access to it, going back to this single unified view of various systems powering a building. So again, it's not necessary, why you might want to build from the ground up. There are already partners that are actually already built these platforms that provide a key service for you. Next slide, please. And just very quickly, so Cognizant's architecture is very much like the previous slide. It ties together all of the key AWS components for a smart building. And from left to right, the sensors and the building management systems connect to AWS IoT Greengrass, which sends data to IoT Core so that we can do management and analysis. Next slide, please. And then we get to the last question, which is, how do I extract value from my data? I'm going to spend about 5 to just 10 minutes just talking about the analytics and why this is so important. On that top part of the set of services, I said that we have IoT services called IoT Analytics. So these are fully managed services that are purposely designed to offload the heavy lifting of you building turnkey, offload the heavy lifting of building turnkey analytics applications. So the IoT Analytics, it has a set of built-in tools for you, literally out of the box, to cleanse data, to transform it, to enrich it, to remove the noisy IoT data. It has embedded visualization or dashboards like QuickSight, and it also has advanced analytics using pre-built ML AI templates. And this is important because data is not structured, and it's noisy, and it comes from tens to hundreds of millions of sources. And really, with these set of IoT services, once it's collected, it goes through the same process: pre-processing, enrichment, store it in a time series database, query it, visualize it, and act on it. Next slide, please. So how do we create a true virtuous cycle, right? So we've talked about the 3 stages, and I've said it's not a stack, it's a cycle. So what we've done is we've enabled the edge to improve over time, which from the data that it collects. So what I mean by that is, in this case, we've enabled machine learning at the edge. And that's important for smart cars, so that they can do self-learning, for trains, for building management systems. So before, it was only possible to implement machine learning in the cloud because of the compute power and storage required for all of the parameters collected from millions of devices. So machine learning was previously only available in the cloud. Now we have, with machine learning at the edge, we still collect data as before, using Amazon FreeRTOS, going through Greengrass. We send it to AWS IoT Analytics, where we cleanse and enrich it. But then we send to Amazon SageMaker for model creation. It's one of our AWS services. So with a deep learning compiler extension to SageMaker, the model is optimized to about 100th of its size. It's packaged within a framework and sent to the edge. It's sent back to Greengrass, where the model runs in a deep learning runtime. And this is critical that enables this cycle, because this not only enables local inferencing and prediction, but as Greengrass continuously sends back data to the cloud, new and improved models are created and sent back to the edge. So this enables this virtuous cycle that we spoke of at the start of the presentation. Next slide. I powered through this, so we're almost done and good for Q&A. So I want to put it all together in one example. And true, it's not a smart city example, but this is a highly complex one, which is Woodside. So they're a pioneer of liquefied natural gas in Australia. They're the world's largest natural gas producer, producing approximately 6% of global LNG supply. So, LNG facilities are some of the most complex things on the planet, and traditionally only critical items were continuously monitored due to the expense. This again comes back to the edge and how sheer location and complexity really prohibits or have prohibited true analytics in the field and at the edge. So Woodside wanted to significantly lower the cost of data acquisition, right? And in this case, from tens of thousands to hundreds of dollars per sensor fully deployed. And they wanted to digitize as many of their assets as possible in the field. So they were able to do that with RTOS and through Amazon FreeRTOS and Greengrass. And so they were able to collect data from the devices in the field, and along with advanced analytics of IoT analytics and visualization, they were able to free up their site workers to focus on value-added activities to drive greater efficiency and safety. So really, again, it comes back to kind of enabling a strategy. So they were able to use the core AWS IoT services, which in turn increased their reliability and safety and enabling their growth strategy. Next slide, please. And lastly, and this is I like to leave this slide in because I think it's really key to call out. And coming right back to the very first slide is, the Internet of Things is not a standalone solution, and customers don't buy the Internet of Things. They buy a combination of technologies to enable a business outcome. And AWS, we understand, and at Amazon, we understand the complexities involved, and of ourselves moved through the same evolution that we spoke about earlier. And in our case, we've implemented the technology that we've just spoken about, and in more than 175 fulfillment centers, 50 of which are robotics. So that's another one of our services. 200,000 robotic drive units, 20,000 trailers. So we're talking about logistics. And again, coming back to the Internet of Things, right? We've sold more than 100 million Alexa-enabled devices. So we understand the Internet of Things and leverage our own technology to securely scale operations, drive efficiencies, and innovate. So, and based on our own experience, we'll continue to innovate on IoT and our services to enable you to drive technology and a data-driven strategy to allow for scale and interoperability.